Okay, look, Calvin, thank you for taking the time to talk to us about containers and EKS. We are really looking forward to hear what you have to say. You guys can take it away. Thank you very much.
Cool. Yeah, thanks a lot for giving us the opportunity to do this. Always really enjoy knowledge sharing. So I'll just kick off with sharing a bit about who we are. We chatted a bit about it just before the actual session started. But Calvin and I both work at Entelect as software engineers, and we're both consulting at Standard Bank. We're in the same team. And for most of this year, we've been working with Kubernetes, Amazon EKS to be specific. I don't think either one of us would say that we're experts in it. The Kubernetes ecosystem is huge. But yeah, definitely big fans of container orchestration and what Kubernetes has to offer. So we thought it'd be great to actually just share what we've learned so far. And we'll try as much as possible to not delve too deep, even though that might be a bit subjective. Okay, and I usually like to share a bit about the why of a certain presentation, why we'd share this one, and not another topic. So as far as we can tell, containerization isn't losing any popularity. If anything, it's gaining more and more traction. And I think you mentioned as well that this has been one of the particular topics that has been requested. And so for that very reason, we thought about how with containerization growing in popularity, businesses are going to typically have environments where, especially enterprise environment, where they will have multiple containers that they'll be running for their applications. And so you want to be able to do this in the most optimal way, and that's where COEs or container orchestration engines come in. So container orchestration helps when it comes to automating deployment, management, scaling, and networking of containers. Let me just not forget to change slides over here. All right. And that's what Amazon EKS essentially is. In the previous talk that I did on Amazon ECS, I mentioned how Amazon EKS is essentially Kubernetes as a service by AWS. It's one of their container orchestration offerings, along with Amazon ECS. Other examples of this would be Docker Swarm, and other ones would also be Apache Mesos and CoreOS Fleet. And the job of a container orchestration engine can kind of be narrowed down to two main things. So it's clustering and scheduling. So with the clustering, I'll cover that a bit later as well. And clustering essentially, pertains to how you have a master node or a master machine and worker machines, and the master node is responsible for maintaining the entire desired state of your cluster, and your worker nodes is where your containers for your applications would actually be running. And then another responsibility it has would be scheduling, and scheduling entails a bunch of different things. So when it comes to scalability, so ability to easily increase or decrease application instances or node instances based on the traffic, load balancing, so making sure that multiple instances of your app are running on multiple worker nodes, and your container orchestration engine manages all of that for you in an optimal way, along with a bunch of other different responsibilities. And so we could jump straight into Amazon EKS, but we just want to cater for the fact that there may be some people on the talk that don't have a lot of Kubernetes experience. So I'll cover the architecture just briefly. There's a lot entailed in it. Definitely can't do Kubernetes in 2 minutes, but at least it will help a bit with understanding Amazon EKS. Okay, so the K8's architecture, so similar to what I shared, that a primary responsibility of a COE is clustering. So you've got your master or control plane, which you'll see over there on the image on the left, and your compute machines, which would be your worker nodes, or your they may be referred to as your instances as well, especially like in the AWS environment. Those would be your EC2 instances where your workloads would be running. And so the master is essentially the brains behind everything. So when, for example, when a worker node fails, your master would make sure that the workload is moved from the failed node to another healthy worker node. So the Kubernetes master is responsible for scheduling, provisioning, controlling, and exposing APIs to the clients. And then worker nodes they can be physical machines or virtual machines, these are essentially your workhorses of a Kubernetes cluster. So they expose like all the underlying compute, networking, and storage resources to the application. So all of these nodes join together to form what you would call a cluster. Some people also call nodes minions. So you'll notice that in this diagram, there are a couple of different components under control plane and a couple of different components under compute machine. So I'm going to touch on those ones briefly. I'll start with master node components. So an important one is the API server. So you may, if you've worked with Kubernetes or listened to talks on Kubernetes, you might have heard some people refer to Kubernetes as being API centric. So your API server is like the main component. It's like the gatekeeper for the entire cluster. So if you want to CRUD any of the Kubernetes objects, it all has to go through the API server, which will validate and configure all the API objects, such as your pods, your services, replication controllers, etc. And so we typically interact with the Kubernetes API server just using a tool called kubectl. So it's a tiny Golang binary. And then other important components to be aware of would be the scheduler and the control manager and etcd. So scheduler responsible for actually scheduling the different pods across the multiple nodes. And then your control manager, you've got different controllers listed under there. You've got the node controller, replication controller, endpoint controller, service accounts, and token controller. So these controllers are responsible for the overall health of the entire cluster. So then in reference to the compute machines or your worker nodes, main components would be your kubelet and your kube proxy, which are highlighted over there right at the top. So your kubelet is the primary agent and it runs on each one of the worker nodes inside of your cluster. You've got your kube proxy. So this is a critical element inside the K8s cluster. It's responsible for maintaining the entire networking configuration. So when you think kube proxy, you can think networking. And when you're thinking kubelet, you can think of this one primarily in terms of if there's an issue with the worker node, for example, the K8s, your Kubernetes master detects a node failure, for example, and tries to recreate the pod on another healthy node, your kubelet will essentially be very vital to this kind of stuff. And then very important as well would be pods. Okay, so these are the actual scheduling units. Inside a pod is where your container is running, in case you're wondering, okay, and where is the actual application? And so your pods will typically have a one-to-one relationship with containers, but in some cases, if it's closely linked containers, you may have more than one running in a single pod. Okay, so how does that actually translate to the EKS architecture? Okay, so the sweet thing about EKS, probably the biggest benefit, in my opinion, would be the fact that the control plane in Kubernetes or the master node is completely managed for you by AWS. So if you can think of all the cool buzzwords that we like about what AWS offers, those are all offered. It is highly available. It's very performant. You have a minimum of 2 API servers, 3 etcd nodes in different availability zones. It also automatically scales to match whatever the requirements may be for the worker nodes that it's serving. And another benefit as well with EKS is that because it's an AWS service, it easily integrates with AWS services such as IAM, EC2, CloudWatch, etc. Okay, so this is just another diagram of the control plane. And so this, like I mentioned, your control plane is completely managed by the AWS team. You have no visibility of it. When you do create your EKS cluster, you will have visibility of the worker nodes that live within a particular VPC. And you will have visibility of that VPC that has your worker nodes in there or your EC2 instances. But in the case where but with regards to the control plane, that isn't visible to you, and it is running within a separate VPC, and it's completely managed by the AWS team. Okay, now when setting up an EKS cluster, something that's really important, a couple of important steps would be, so with regards to your VPC, you need to have your DNS hostname and resolution support enabled, so that the nodes can actually be able to register to the control plane. And then another very important step would be you need to decide on a networking mode. So your networking mode is essentially deciding on the accessibility to the API server for your cluster. So you've got three different types of networking modes. You've got public and private endpoint only. And so, for example, with public, then all of the traffic for your VPC will have to, so your VPC will actually have to have an internet gateway, and you'll also have to have a NAT gateway in the case that you have private subnets within that VPC, where your applications will actually be running, or where the EC2 instances will be running. And you want to have that NAT gateway so traffic can actually flow from there to the internet as well and have that traffic. And so the API server is publicly exposed. So that's when you have a public endpoint only enabled, and that's the default one if you're to set up an EKS cluster. Then there's also public and private. And so with public and private, so the API server endpoint is publicly exposed, so you can be accessed over the internet. My word, today's a day of random pop-ups coming. And in addition to that, their EKS will set up a managed elastic network interface for you, so that the worker nodes will communicate with the control plane within the AWS network, and just directly between the worker nodes and the control plane, traffic flowing through that particular elastic ENI, as opposed to the public endpoint where traffic will leave the VPC from your worker nodes and communicate with the public endpoint. And then lastly, you have private only. So all of this is within the VPC. And so if you want to communicate with your control plane, you'll actually have to be doing this within the actual virtual private cloud on AWS. And there's a managed EKS, there's an EKS managed ENI that is deployed. So you don't manage that, and traffic will flow through there when communicating with the particular control plane. Okay, then one of the gotchas as well, very important when setting this up. Obviously, if you're going to have a master node, which is essentially, these are essentially just virtual machines in this particular case, and you've got worker nodes, which are also virtual machines. And if one is controlling the others, then that means that you need to have traffic flowing between them. And so in the case of in the AWS landscape, the firewalls that protect instances are security groups. So you need to make sure that you set up the right kinds of security groups. So very important ones obviously would be for the security groups for the control plane and the security groups for the worker nodes. There is good AWS documentation on the ports that you should have opened up for the kinds of traffic that you want to have, for the traffic that you want to have flowing between your master node and the worker nodes, as well as traffic between the different worker nodes. And then depending on the network mode that you set up, so let's say you went private and public, or if you went private, then in that particular case, you also want to have security groups for your VPC endpoints. So let's say the container images that you're pulling are from ECR as opposed to Docker Hub or another repository. What you can do is you can set up a VPC that communicates with the ECR service, and that traffic will flow within the Amazon network or the AWS network, and you'll just need to make sure that you also configure security groups for each one of the VPC endpoints that you do set up in that regard. If you do know this, so with VPC endpoints, you can actually also configure them to work with external AWS services. That's something that I haven't tried before, but you can definitely look into that as well. But those are the important security groups to consider for control plane, worker nodes, and in the case of your networking mode having some privacy, then you will need to have VPC endpoints, security groups for your VPC endpoints as well. Okay, I'm gonna hand over to Calvin now.
Cool, well, thanks, Luke. So EKS Pod Networking, essentially, how do applications talk to each other, or applications talk to external services or expose services on the network layer in Kubernetes. By default, every Kubernetes cluster deploy ships with the AWS VPC CNI, Container Network Interface. What this does basically is it connects your pods directly to your VPC. So the exact same, basically a pod will get assigned an IP address that's within your VPC side of range. And obviously with that comes a whole bunch of benefits related to AWS. So if your pod is connected to the AWS network, you can do VPC flow logs, you can easily do security groups, connect in private to databases and stuff without worrying, managing different networking and routing and stuff like that. Obviously, there are some side effects that are affected. So, for example, because the pods on EKS, you tend to scale to the hundreds of thousands of pods because that's what Orchestration does. But with the VPC CNI, you can only obviously you're limited by your SATA ranges in your VPC. So beware that if you set like a /24 on your VPC SATA range and you start scaling up to 3,000 pods, you're going to run into issues with that. Also, you have to watch when you choose a node. Basically, the work node that Luke described earlier is you have to check on the number of network interfaces on that node type. For example, if you look at the first one, it's kind of, if you select an A1 medium measure node type, this only has 2 network interfaces, and each network interface can have 4 unique IP addresses. So then theoretically, if you had this node running on your EKS cluster, you can only run 8 pods on that node. And obviously, so what will happen is your node might have tons of CPU and tons of memory still available, but you've maxed out the IP addresses. So you're actually underutilizing the node, but you're paying for the full node. So that is one of the downsides to the VPC CNI. And but there are other options. So if you are like in a corporate environment where you're restricted to the number of IP ranges you can remove the AWS VPC CNI and install a third-party network interface, be it a Calico one, and that will give you infinite amount of IP addresses, but you lose all the benefits that interact directly with AWS core features like VPC logs, security groups, such. Cool. Luke, if you can go to the next slide. Cool. And just now, how does pods and nodes interact with IAM? So authentication to your node is done through IAM. Through IAM roles, you can assign, you can attach policies to the IAM role, what they can do with the cluster and stuff. But the actual actions within the cluster, you have to still is done through RBAC. So Kubernetes native role-based access control. So they, when you create a cluster, you automatically get a AWS auth config map that gets created for you on your cluster, and that is where you can attach and set up IAM roles, and then you define in which groups and access this IAM role has. By default with AWS, when you create a cluster, the role that creates the cluster automatically gets assigned master access on the cluster, and that can't be taken away or revoked later. So whichever role creates the cluster, that role will have master access to cluster for the full life cycle of the cluster. And in that role, when you actually go into your AWS auth config map, you won't even see that role. The next slide. So this is just an example of the AWS auth config map. So you'll see even your nodes who need to access when they need to register with the control plane, they need access to the API server and the cluster, and it's also done through the same config map that a user would need. So in this example, we'll see here you just add the role on of that you attach to the node, for example EC2, and you'll see this this will get attached to a username as just a system node, and all it will have is bootstraps and node access on EKS. essentially it will just have access to register with the Kubernetes control plane, and then that's when the control plane will start injecting your kubelet proxy and your kubelet to act as a functioning worker node. And in this exact same config map is where you'll add users and configure their groups and stuff like that. And then you can create role bindings and cluster roles, which get attached under these groups. Thanks, Luke. Next one. Cool. One of the newer features and really needed features on EKS was IAM roles for service accounts. So in the past, if a pod, for example, had to talk to a particular AWS service, say it be Secrets Manager or RDS or Lambda, you need to give this pod access to AWS, but there was no mechanism natively to do it. So what ended up happening was you end up giving the EC2, the role that is attached to EC2, you end up giving that EC2 role access to many different services, be it Lambdas, RDS, Secrets Manager, and even though only one pod necessarily was using that service, every pod would have access by default because they're all sharing that same node role. There were external party workarounds like Kube2IAM that could help you with this, but then AWS released IAM role service accounts. So essentially, you can attach an IAM role to a service account, and then that service account would get assigned to that deployment or pod. And then essentially, what will happen is the pod would make a request to, so the EKS automatically gets generated an ORDC provider on IAM, and then when a pod makes a request to EKS to AWS, it will get a token from the ORDC provider. That token gets saved. Those temporary credentials to AWS get saved on the pod, and then when a pod needs to talk to a specific service, they'll talk to AWS with that token credentials, and that token credentials is where you set up your IAM policy. So this pod has this service account, and it can only talk to Secrets Manager. And then when it makes an API call to AWS, it can only do Secrets Manager. And clearly the benefits of this is the least privilege to credential isolation and auditability. So now on your CloudWatch logs and CloudTrail, you can see which IAM role made which request to AWS, and you can see what the actual pod did to your AWS account. So that is a nice feature that helps a lot. Looking at the next one, thanks. Cool. And one of the very new features for EKS was you can now use EC2 security groups for pods. So you can imagine some Kubernetes clusters are run multiple workloads. So it could be for different teams that are running different projects, or even sometimes one project is running multiple versions or different environments in one Kubernetes cluster, and you need to segregate these things. Basically, if you're running dev and test in one Kubernetes cluster, so you can use namespaces for that. But even within a namespace, if you wanted to finer grain your access control, so can pod A talk to pod B? You couldn't really use native AWS components for this. So you'd need to install like Calico policy networks to restrict which pods can talk to each other. But now you can use AWS security groups to attach them to a pod, and you can define your microsegmentation of your microservices. Microservice A can talk to microservice B, and B can talk to C, but A can't talk to C, for example. To use security groups for pods, you have to be running Kubernetes version. Okay, that's 1.7. So that 1.173 is incorrect. Sorry, it's 1.7. Not ignore the 3. Yeah, you can't use it in conjunction with Calico policies. So a lot of teams are already running Calico policies, which is like a tried and trusted way to do this, and it's been running for it. There would be a migration process to actually start using native AWS features, but at least now you don't have to install a third-party application onto your cluster. And this feature is not available if you use EKS with Fargate. So you have to use managed worker nodes or self-managed worker nodes. Looking at the next slide. Thanks. So yeah, just touching on EKS worker node types, you get two main types, standard EKS and EKS Fargate. And I'm sure you all know about EKS Fargate, the benefits of it, where you just basically, in this example for EKS, you just define your pod or your deployment manifest and you deploy it onto EKS Cluster, and AWS completely manages everything else. From the scaling of your pods, the management of your operating, your OS, to security patches, the Docker runtime, to all control areas. All you have to worry about is your application and the manifest. For normal EKS, you have to install things like horizontal pod autoscalers and cluster autoscalers, and your different, and you need to choose your EC2 instance type, and then obviously that's when you have to take in consideration the number of network interfaces, as we discussed earlier. You could get a limitation like that. All that is eliminated with EKS Fargate. Cool. Thanks, Luke. Cool. I just want to touch on controllers. It's one of the core building components of Kubernetes, and it's related to many things, and many patterns are based off the controller pattern, like operating pattern. Essentially, the controller pattern is how Kubernetes manages all applications and state of the cluster. So essentially, when you tell Kubernetes to deploy a pod, the controller now will observe that pod, and if something goes wrong with that pod, basically it looks at the manifest. If there's a difference, the controller will act on that and it will observe it and it will fix the difference. So essentially, for example, in a deployment, if you specify you want 3 replicas of your pods, now there's a controller watching it in your control plane. It'll spin up 3 pods. For example, say one pod goes down to some application error, the control plane will see a diff, and then it will act upon that diff and it'll deploy a 3rd one back. And the cycle continuously happens to make sure that all your manifests in Kubernetes are continuously up and running, and the cluster itself is continuously up and running and in a manageable state. But now this controller pattern can be used in other areas that are not the core stone of Kubernetes. A lot of open source projects have utilized this controller pattern for their own purposes. So I've just listed a few here that controllers that interact directly with AWS. So if you create a deployment that exposes some sort of endpoint to the public, and you wanted to create a DNS record you can deploy this EKS external DNS, and you just add some tags basically to your deployment or your ingress, and then this external DNS controller continuously will find this deployment or this ingress. It will then the root 53 DNS record for you, and then continuously monitor it. So if your load balancer goes down, it will delete that DNS record from root 53. If it comes back up, for continuously that loop. Same with external secrets. If you wanted to create Kubernetes secrets, you can use external secrets. Basically, your secrets would store in the secrets manager, and then the control plane will continuously monitor that the secret in secret manager and the secret in Kubernetes are in sync. So if you update the secret in secrets manager, it updates the Kubernetes secret. Cluster autoscaler, similar. If basically cluster autoscaler, what it'll do is if it detects that you're running out of CPU, it'll basically tell the EKS to scale up the node to 3 or 4 nodes, and continuously monitor that based on your CPU and your requirements that you've set. AWS Ingress Controller, if you define an ingress on Kubernetes, with this controller will automatically create an application load balancer for you on AWS, and it'll keep those 2 in sync. If you update the routing on your ingress, the controller will automatically update the ALB routing and all those paths. And then one of the main features is the GitOps flow, where you can use Flux or Argo to have a repo, like in code commit, for example, we have all your Helm charts or your manifests and then it'll deploy those manifests or Helm charts directly onto your Kubernetes cluster, and the control plane will continuously keep them in sync. So if someone pushes new code to your manifest, Argo or Flux will automatically apply that to your cluster, and that's a very simple way to use GitOps, and it's becoming the preferred way to manage and deploy things onto Kubernetes instead of needing to install a big third-party application like Jenkins or something like that. It's lightweight, it's simple, and it's easy to use. Cool. So that's just how controllers can be used to leverage other AWS services. Can we go to the next one? Yeah. So this is basically the EKS build-up that Luke will be showing us through Terraform, just roughly of how you would deploy an EKS cluster through Terraform. Luke, if you want to jump in.
Okay, cool. I almost forgot to unmute myself over there. So yeah, we're going to be showing you an example of an EKS cluster built out using Terraform, and the networking mode that we've gone with is both public and private. So as you can see in the diagram, I hope it's clear enough. There is an EKS managed ENI over there for communication between the worker nodes and the control plane, so traffic will pass through there. And then for any kubectl commands that I want to run, I would those would go through the NLB that communicate with the API server in the control plane. Okay, so I'm gonna stop sharing this and turn over to the Terraform side of things. Okay, I take it you can still see my screen?
Yes.
Okay, yep. Perfect. Okay. So what we've got over here are the two main modules. And so in this module over here, which is essentially like a grouping of all the relevant resources for particular things that I want to deploy. So in this case, I've called it VPC for EKS. So this module contains all the resources for the networking infrastructure that I want to actually have set up for my EKS cluster. And then the second one over here pertains all the resources, the relevant resources for the EKS cluster itself. Well, we'll start off with the VPC because that's kind of like the groundwork that's required before you can actually start, before you can actually deploy your cluster. And so some of this might be similar to the source code that I showed in the previous talk. And so in here, I'm setting up my VPC. As I mentioned, it is important for both DNS support and DNS host names to be enabled. You also need to make sure that you have the relevant tags. This is also a very important requirement when it comes to EKS. So you'll see that I've put a tag over here, and then that tag will have my cluster name, and the same is required for your subnets as well. So this is important for, especially in the case of load balancers. So if you have internal load balancers and public load balance, internal load balancers or public load balancers, and you want them to be deployed to a particular subnet, then the tagging is also important. So this is one of the ways that EKS will know where which subnet a particular LB should be deployed to. So I start off with just setting up my VPC, and here I've got a private subnet and a public subnet. In addition to that, so I've also got an internet gateway attached over here. So with private and public mode, you actually don't need to have this, but I thought to just include it for the example where if someone did want to have a completely public setup. So you'd have your internet gateway over here. So that means I will also be setting up a NAT gateway because of the resources that will be in the private subnet, and creating an additional route table to the default one, and then just creating an association with that route table and the public subnet. Okay, so once we've created our VPC, like I mentioned, you create a NAT gateway as well for those that want to have a public networking mode. And very important as well for private would be the VPC endpoints. So in this particular case, you'll see I'm creating a VPC endpoint for ECR Docker, ECR API, as well as for the worker nodes. I've got EC2 set up over here and S3. And S3 is here because the actual image layers for the container images are stored in S3, even though you don't see them there. So you do need to have a VPC endpoint for that as well. And in this particular case, it'll actually be a VPC gateway for S3. Right, and so when you set up VPC endpoints, as I mentioned earlier, it's very important to make sure you also have security groups set up for those, so that that traffic can actually flow correctly. If you forget this step, then you'll probably run into an issue where your worker nodes are unable to register to the control plane because the traffic is failing to actually flow through there. So make sure that you have the relevant port permissions for the security groups for the VPC endpoints as well. Okay, and then once we've set up our VPC endpoints, we can move over to the EKS cluster. Part of the reason why I'm kind of just focusing on the main parts of this is because I understand that maybe not everyone on the call actually uses Terraform or has any kind of proficiency with it. Maybe you use CloudFormation, or you typically use the console. So I'm just highlighting the different components and how you would be doing that in Terraform. Okay, so then when we move over to the EKS module itself, you want to make sure to start with creating the roles. So your cluster role, your node role, and your security groups. And the reason for this is because you want to make sure that the relevant, because the roles obviously will have particular policies attached to them, and those policies have the relevant permissions for the various API calls that are being made under the hood. And so to avoid running into any issues, you want to make sure that all the necessary doors are unlocked or gates are open for the traffic that has to flow through there. So that is the first step. You want to make sure that your cluster role is created. The same thing will apply for your worker nodes, that the role is created for that. And the cool thing about this is you've got the documentation available online, and it will show you the relevant policies that you'll need to have set up. You can obviously add additional policies depending on some of the resources that you want to apply to Kubernetes, but you can easily find out what the right policies are that you need to have for your node roles as well as your cluster roles. And with regards to the security groups, it's very similar as well. You could find the relevant information for your for the security group traffic that will be for the traffic that will be required for the security groups for both the cluster as well as the nodes. Okay, and then once you've set that up, the next step would to essentially be to create your cluster. Okay, and this takes a bit of time. From what we've experienced, it typically takes about, on an average of 12 to 15 minutes to get set up. And it is pretty straightforward, even just in terms of the requirements. You want to make sure that you've already got all your VPC steps set up beforehand, and then you can apply those configurations over here. So you would essentially configure the relevant subnet IDs, the endpoints. So this is for the networking mode. You can see over here, this is where you would set the private and public access as well, and the relevant security group IDs for your cluster. Okay, and then the OpenID Connect provider, which I think Calvin touched on as well, you can also set that up quite easily over here. And once you're done with that step, the next thing will be to set up your EKS node group. And your node group obviously doesn't take as long as setting up the control plane. That might also depend on the number of nodes that you are creating. And I should note that it is possible to actually set up your own launch template for your EKS node group. But even if you don't use a launch template, it will the nodes will obviously be a part of an auto scaling group. But if you want to have a lot more hands-on control in terms of your auto scaling group, you can configure a launch template over here. Okay, cool. And so I've already applied it. And so my EKS cluster is already set up. And the applications that I deployed were a products microservice, an orders microservice, and a GraphQL microservice. And so in addition to that, instead of using the AWS ALB ingress controller, I'm using the Nginx ingress controller, which essentially does a similar job to what Calvin pointed out when he was elaborating on the ALB ingress controller. So it creates a load balancer and manages the traffic that gets forwarded through, in my case, to the GraphQL application. And so what I did in addition to that is my NLB is actually internal, and so I instead created an API gateway, which then forwards traffic through to the through to a VPC link, and then the VPC link forwards traffic to the internal NLB. And so what we have over here is the endpoint that gets exposed and is actually forwarding traffic all the way into the cluster itself. And if you're not familiar with GraphQL, don't worry about it. I'm not going to waste your time with delving into that. I know it's already a lot to try and digest everything related to Kubernetes and EKS, but this is just to show you an example of the application itself. You can get rid of that. There you go. So this is just an example of showing you how the actual deployed application itself looks when it's working. Okay, I'm gonna stop sharing now, and yeah, Calvin and I will take any questions that you guys may have.
Yeah, that was pretty cool. Thanks, Luke and Calvin. That was interesting. I see we have a few questions. First one from Hendrik. Hendrik, do you maybe want to unmute yourself and you can ask it? I was going to share my video. Everyone's welcome to share your video.
Can you guys hear me?
Yes.
All right. Never know if my mic is working or not. Right. So I was just asking, experience in the real world for EKS plus Fargate. How does it pan out? Does it work as advertised? You know, are there any types of workloads, jobs that is more suited or less suited? You know, anything that doesn't work at all? Sure.
Yeah, I think that's a question that a lot of people have been asking when they announced EKS Fargate. Should they start making that transition? I personally haven't worked in like a real world experience with EKS Fargate, but what I've seen and what I've read out is that it's more suited for smaller based applications. So where your cluster is not running multiple different workloads for different projects, because you can't do the security group segmentation of your clusters. You don't have that foresight of what's actually being separated. And also, why this gets suited for small based applications is it can be cheaper, actually, surprisingly, because if your small based application, say you choose a node type and you're running 3 pods, for example, you might only be using 20% of that node, but you're paying for the full of it. Where with Fargate, you only pay for exactly what you need. So for small based applications, it would be cheaper actually to use Fargate. And also, because Kubernetes ecosystem is quite large and as well, like third parties which you add onto your cluster, you might miss that with EKS Fargate. So in terms of your cluster and your environment being portable to another EKS Kubernetes environment, maybe on GCP or Azure, it might not be as easy as if you're running just straight EKS.
Okay, yeah. Thanks. Thank you.
Everyone, if you don't mind, you can complete the survey there that I posted in the chat, and then we will do a lucky draw at the end for a $25 credit, or we might do 50, or I might do 2 25s, but we'll do a lucky draw there if you complete the survey. Hendrik, I can also just mention on that Fargate, but I'm not speaking about EKS specifically, just I've been using Fargate as well on a few projects, and it usually works great. Almost like Calvin said, is when you have a few small applications. So as soon as you start getting high throughput applications, then it's almost better to go back to your containers like EKS and ECS, because then you can pack them more densely on a single container, or on a single host, and that will then be cheaper. But if you have a very spiky workload, then Fargate should be better, or I think that is what it was designed for. Okay, then we have another question. Abu Bakar. I'm sorry, I probably butchered your name.
Are you able to hear me? Abu Bakar.
Okay.
Yeah, I just wanted to find out. I have used EKS CTL, I think like a year and a half ago, but it did not meet my requirements. I can't remember the reason, and then I just stopped for a while. I just wanted to know if have any of you guys used EKS CTL to actually run your infrastructure or deploy your infrastructure. Basically, that's basically what it's for, and yeah.
Sure. Yeah. So we don't really, well, unless Calvin uses in his spare time, but yeah, like I don't really work with EKS CTL. What I do know is that there are certain things that we would run into with Terraform Community Edition that when we did research, we would see that it would actually be some of those steps would be easier when it came to setting different configurations up with EKS CTL. So I think there's a bit of give and take over there.
Yeah. When you were exploring it, was that a while ago or was that recently?
No, it was quite a while ago.
Yeah.
There are some nice features of EKS CTL. Obviously, it is the AWS's way now to deploy their Kubernetes to deploy EKS clusters. So it's easy to, in your EKS CTL, update the AWS auth config map to add IAM roles and stuff, where it's not so easy to do that with Terraform. You have to like do some workarounds. And obviously, because it was built by Weaveworks, they also have another tool called Flux for GitOps. I'm a big fan of GitOps. So if you wanted to turn your EKS cluster into a GitOps cluster, that is literally a matter of 2 lines of your code, and the cluster turned into where with Terraform you first have to deploy the cluster, and then the GitOps is an add-on. Where with EKS it can become part of your deployment.
Okay, cool. Thanks, guys.
Yeah.
Luke and Calvin, have you guys heard of CDK8s? Or it's basically CDK, if you know AWS CDK, which basically just sits on top of your cloud formation, cloud formation. But you can now basically use that, and then it will output Terraform scripts for you, and you can execute that. So maybe check it out there if you haven't. Have you yet? Or?
So I haven't used it, but someone did send me a couple of messages saying that I should really consider looking into it and using it. So
I think it also simplifies the amount of Terraform that you would have to write.
Yeah. I'm someone who doesn't really like change, so it'll probably take me a while.
Yeah. Okay. I do not think a lot of people filled in the survey. We don't have a full house. Let's just see. Okay, we have 3 people. I'll send all 3 of you an AWS code for $25. I got some free credits, so it'll be like Oprah. Like, you get a credit, you get a credit, everybody gets a credit. Okay. Thanks, guys. It was actually, I did learn a few things, even though I'm not the biggest fan of containers.
Cool. I'm glad you guys enjoyed it.
Yeah, and we'll keep coming back with containers till you change your mind about them around.
Okay, do that. Okay, thanks everyone. I'll catch you again on the next AWS Pretoria meetup. Cheers.
Thank you very much.
Cheers, guys.
Cheers, guys.